Elasticity. Worldwide annual sales of smartphones in 2012-2013 were approximately Q equals negative 6P plus 3,030 million phones at a selling price of P dollars per phone. We are given the supply equation in terms of the price, where P represents the selling price in dollars and Q represents the number of smartphone. Part A. Obtain a formula for the price elasticity of demand E. The price elasticity of a demand E is given by the equation negative dq dp times p over q, where dq dp is derivative of q, but q is given. Q is negative 6p plus 3030. Taking derivative of this supply equation with respect to the price, we get dq dp differential equals derivative of negative 6p with respect to p is negative 6, and the derivative of 30 with respect to p is 0 because it is a constant. So dq dp is negative 6. We then plug this into the elasticity equation. Negative dq dp is negative 6 times p over q, but q is given negative 6p plus 3030. Don't forget to replace the denominator q with the given formula in terms of p. And also don't forget that the formula for the elasticity already has a negative sign, so we would simply rewrite that first negative sign. dq dp by itself happens to be negative 6 in this case, and negative 6 is positive 6, and so we simplify to get positive 6p over negative 6p plus 3030. And this is the formula for the price elasticity of demand E. E is a formula in terms of P. It is a function of P. It is a function of price. In 2013, the actual selling price was $335 per phone. What was the corresponding price elasticity of demand? E is the function of P, and so we will simply plug the price P into the formula for the elasticity. The price is 335. This is 6 times 335 over negative 6 times 335 plus 3030. We simply replace P with 335. Evaluate this, we would get 1.9706 rounded to 2 decimal places. This is 1.97, and it is in terms of the percentage for the elasticity. Now, to interpret this, E is 1.96, which is more than 1, so it is elastic, and we would say that if the price is increased by 1%, the demand would, it is important even though the sign of 1.97 is positive, but to interpret the elasticity, when the price is increased by 1%, we would say that the demand goes down. So the demand is decreasing by 1.97%. Lastly, for part C, use your formula for E to determine the selling price that would have resulted in the largest annual revenue. The largest annual revenue is when the revenue is maximized. Once we found the price that would maximize the revenue, we would also need to find the revenue and round it to the nearest 10 million. The revenue is maximized when the elasticity equals 1. This is the unit elasticity. But the elasticity formula, we computed it from part A. It is 6p over negative 6p plus 3030, and we set it equal to 1 to solve for p. 1 is 1 over 1, and so cross multiply, we will get 6p times 1 is 6p equals 1 times negative 6p plus 3030 is negative 6p plus 3030. Add 6p to both sides of the equation to get 12p on the left, and on the right hand side we get 3030. Solve for p, we will get 252.50. And this would be the price that would maximize the revenue. To find what the revenue is, we simply use the equation, the revenue equals the price times the quantity. But again, the quantity is given negative 6p plus 3030. So we get the revenue equation. To find the revenue, we plug in p. P is 252.5. Replace p with 252.5. We get 252.5 times the quantity negative 6 times 252.5 plus 3030. Evaluate this to get 382,537.5, and round it to the nearest 10, we have 382,540. The unit is $1,000,000, or this is 382,000.54 billion dollars, and this is the maximized or maximum revenue.